Good morning, good afternoon, good evening, everyone. Today we are going to find out how to capture requirements. Typically, in modern software engineering practices, we don't detail out every detail of requirements, but we only capture key features and the ASRs. When we say capture, we mean how to represent, which in turn means how to document. Perhaps the only way to capture step-by-step details could have been through a detailed document, which, as I mentioned earlier, is something nobody does today. The reason is the pitfall of such upfront detailing is that a lot of intended details is missed out in the beginning, and thus the document, contrary to assumption, doesn't fully capture all the details that it has set out to achieve. However, it doesn't mean we won't do text documentation. We still do, but at a higher level, and most often in combination with the rest of the methods discussed in this session. The data flow diagrams, or DFDs in short, are an important way of showing how data is generated, where it is stored, how it is consumed. We'll get into the details soon. Business use cases are pretty popular in capturing some key business functionality, but it may not be a good way of capturing ASRs. Being diagrammatic and simplistic in nature, it succeeds in explaining the requirement very quickly and at times even at a glance. In modern days engineering practices, user stories is perhaps the most commonly used form. This is an engineer friendly way, which is important because at the end of the day, it is the engineers who will have to deliver the product. Without being too formal about one approach over the other, we often mix all of the above because the point is drive home the point. It doesn't matter which approach we take as long as no important need to know details are missed out. It is simple to understand. The mantra is as much as necessary, as little as possible. Usually, any business process or system is composed of multiple subsystems or sub-activities. For example, search a product, add to cart, place order, etc. Data flow diagrams or DFDs explain very clearly how data is generated, stored, and flows from one system to a subsystem or another system, including external ones. Thinking of a system in terms of how its data flows really helps to understand the system better and fast. While a DFD diagram limits itself to a data flow, it surely gives a general overview of the entire system, what subsystems exist, etc. And therefore, it defines the scope because it clearly tells which subsystems are external ones and therefore we won't develop. It creates an idea about the scope of the system to be developed. As the DFD shows data flows through systems and subsystems, creation of DFD forces us to understand the business processes, sub-processes, data, system, subsystems, etc. Then there are two types of DFDs, logical and physical. Logical DFDs are the abstract representation of business processes and events that take place which impacts data generation, storage, flow. Physical DFDs, on the other hand, lays out more technical detail about the data, overview of its structure, where, how it is stored, what kind of security at rest is required, what encoding is needed for data transfer, etc. Let's now have a look at a business process of a customer placing an order. We'll try to create a very simplistic DFD. This diagram uses certain shapes. These specific shapes helps the reader of the DFD to understand the elements. Typically, an ellipse is used to show an entity. An entity can be a person or another system or another object that can have data stored about them. A process is denoted by a rectangle and a piece of dump data is denoted by an incomplete triangle. A very important note here. Going forward, you will learn many different kinds of diagrams and their standard graphical notations. However, there is no law that can put you in jail if you use, let's say, a parallelogram for representing data or a triangle for representing entity. The shapes shown here are common and everyone knows, but they still are not hard rules. Just follow what you see around the way people use these shapes and you will be fine. Continuing with our DFD creation, we detail a little now. The customer places an order in the order process system, which in turn creates an order data, passes it to the warehouse system. Furthermore, the order process updates the inventory data. A report management process this inventory data and notifies the inventory manager about a change in the inventory. The inventory manager requests the inventory management process, which in turn notifies the inventory supplier. Hope it is clear now. While creating a DFD, we need to remember to follow certain rules. An entity cannot directly communicate with another entity. It can happen only through a process. Entity cannot directly send data to any persistent store unless it goes through some process. Same applies to data from a data store. It needs processing before it reaches an entity or another process. Data cannot hop between different data stores unless it goes through some process. Now look at this diagram for some arbitrary project. Are you able to detect any flaw? Think about it. When creating DFDs, you need to remember to avoid few simple caveats. Every process has one or more output. A process cannot just get inputs and leave them there without passing it to another process or a data store. There is no process which gives an output without any input. Every process has to have a consistent and relevant input and output pair. What has an employee's payroll got to do with a customer? Next, we'll learn about UML use case diagrams and of course, what is UML in the first place. Please do subscribe, like, share if you're benefiting from these sessions. Thank you.